First, we use the Refresh Button widget node to create a global update control button. Then drag in a string widget node as the city address text input port, name the variable as location, enter Cambridge, Massachusetts, USA in the default value input box, and edit the text in the label. Next, drag in OSM POIs and OSM Boundary Map from open datasets. Link the string widget to the boundary map and set the place name as the variable location. Executing the OSM Boundary Map node will get the city boundary of the city of Cambridge. Then connect the OSM Boundary Map node to the OSM POIs node. This node will obtain the POI points of the Open Street Map based on the boundary of Cambridge City. The default selection is Restaurant under the Amenity class. In order to set more amenity class options, we can click the OSM POIs node, view the description, and click the Open Street Map Tag Info link. Select amenity in the web page and sort. Copy the first few hotspot values to Notepad and keep the tag value. Go back to KNIME, drag in the single selection widget node, and copy the value in Notepad to possible choice, add hospital as an optional category of POI, and modify the label description. Connect it to the OSM POIs node, and adjust the flow variable setting so that we can get any POI data under any city. In the second step, we will establish a square grid to summarize and visualize the number of POIs, which is similar to the function of a spatial heat map. First, drag in the Create Grid node, because it allows specifying the value of the edge length. We can introduce an integer widget node to set the input window. After connecting and testing the Create Grid node, it can be found that the grid side length unit in the Create Grid node is consistent with the projection system of the input Cambridge boundary geographic data, and its unit is degree, so projection system transformation is required. Drag in two projection nodes again. The former is set to EBSC 3857, and the latter is set to EBSC 4326, linking the nodes to convert the unit to meters before executing Create Grid. After executing Create Grid, the unit is changed back to the original projection system. Drag in the Spatial Join node, use the column filter to keep the key parameter column before execution, and use math formula to establish the value of count equals 1. Then use the math formula to construct an integer index for the grid data to facilitate subsequent attribute links. We can handle the null value of OSM data through the missing value. Connect the POI data to the upper input port of the spatial join. The grid data is located at the lower input port, and set the relationship as left join and intersect. Run node. In this way, all POI points will be attached with the attribute value of the grid data that intersects with it in space. Here, it mainly refers to the index of the grid. Use the Group By node to summarize the count or category of POI points based on the grid index value. Then join the aggregated value back to the grid data, and use the Missing Value node to handle blank values. Finally, we use the Geospatial View node for visualization. The third step is to select all nodes, package them as components, and execute them. After execution, right-click and select Interactive View component to view the dashboard that can summarize and analyze global OSM data. Here we can choose any location address, amenity tag value, or grid length size, and then update the map through refresh. Here we explore the cases of the United States, China, Germany, and Brazil.